Welcome to Beyond Bandwidth, Leviton's podcast series where we dive into network technology's hottest topics. I am your host from Leviton Network Solutions, Roy Chamberlain. Leviton's Mike Connaughton meets with Robert Henke today. Robert is a partner at the manufacturer's rep firm WestCal Technologies. To be or not to be structured cabling? That is today's question. In episode 8, season 2 on AI data centers, we discuss the reasons why structured cabling is the design choice for most of these spaces. Latency, insertion loss, distance, pathways, airflow, future migration are all aspects which affect the overall performance in any network system and are exponentially expressed in an AI data center system architecture. These guys are in the trenches with the experts on this topic. Learn from their involvement so you can make the best decisions for your next data center design project.
Hey everyone, this is Mike Connaughton, Senior Product Manager here at Leviton Network Solutions, and welcome to this episode of Beyond Bandwidth. And I'm joined today by Robert Henke of WestCal Sales. Thanks for joining us, Robert. I appreciate it.
Well, thanks for the invitation, Mike. Glad to be here.
All right, just to start, if you wouldn't mind introducing yourself and giving the listeners a view of your background.
Easy part there. So, graduated college, came to Northern California, and my very first job out of college was actually Annixter, or Annixter Brothers back then. And we were selling network cabling and connectivity in 1988. Things like MALs and CALs and ThickNet and ThinNet and ArcNet. And it was the Wild West of computer networking because there wasn't really a standard solution. Ethernet was not the platform. There were all kinds of different languages being used. So that's kind of where I stepped in. So I learned a lot about the other, WANG and all kinds of coaxial solutions. So I was around for the Levels launch with Annixter, which was a way of grading UTP cabling. And nobody knew at the time that was going to be the upcoming standard for TIA, which was then EIA TIA. That's kind of where we came in. And pretty much ever since then, I did, worked in the electrical side to a degree, but have always been around cabling, connectors, networking, for my entire life. 1995, got my RCDD, helped introduce back in the early 90s, Category 5 into the marketplace, and was training contractors and customers on installation methods, technology, and how the TIA and EIA wanted you to do it back then. And so fast forward, I'm a partner in a firm called WestCal Technologies. We are manufacturers' representatives, and Leviton is our premier line that we go to market and sell.
Hey, we're glad to have you. So 2 things that you said there kind of triggered something. You mentioned WANG, and that's going to make my brother-in-law very happy. He used to actually work for WANG when WANG was a thing. He loves it when I bring up WANG in my history lessons of cabling and connectivity.
Twin Axe and IB, we can go into token ring, 150 ohm. There was some. It was wild back then, right? I mean, you have so many networks to learn. It's completely simple now, or I should say, much simpler now, where we have Ethernet and it's been standardized.
And that's the other thing that you said during that is in the early days when there was kind of not a million, but certainly a large selection of choices people had to make, and it wasn't clearly standardized. People kind of figured it out by putting it together. That's not unlike the AI realm today. There's not a defined way to do it. I mean, you have reference standards by people like NVIDIA, but certainly how do you actually implement it? People are still figuring that out. It's
100%.
That makes it kind of fun.
100%. And, it's back to needing to inform the marketplace of the options, which, is fun for somebody in my position where, my highest value is to try and help people create effective networks that last a long time and get them the largest ROI for their computer dollar.
All right. So in that vein, what types of customers do you hear about that are asking about AI infrastructure?
Wow, that is a fun one. It's pretty diverse, but I will tell you that, number one, we get calls from people inside of tech companies. This could be everywhere from a switch manufacturer like a Juniper or car manufacturer like Tesla. Everybody's got data centers and everybody is looking into AI right now, or high performance compute, if you will. And nobody's, as you said earlier, nobody's quite sure how it's done. Everything is very manufacturer specific, circa back into the 80s, right? And so um, they call me and I come in and talk to them about, their needs. We can get into that later on. I guess towards your question, so we get the tech company and then we get integrators as well. Integrators, a little bit different. When I use the word integrator here, I'm really talking about companies like Foxconn, Supermicro, Lambdas, who may take the NVIDIA, may take some from Intel or AMD chipsets and build their own computers that will actually act as the AI HPC platform that they're launching. And so they want to understand the ways of connecting it. And it's different depending on the application that they're trying to solve at the time. And then, so beyond the integrators that are building the racks and shipping out the complete units to the customer, then you ultimately have contractors who put in the cable plant in those job sites where the integrator cabinets show up from the Supermicros and stuff to be installed. So there's a lot of areas where we have to address and help people understand what the needs are of AI HPC.
So, I mean, clearly it's a big diverse group, which is
Yeah.
great. Kind of cutting across, like maybe it's different for each level, but what types of concerns do they bring to you? Like why are they even asking you a question?
Well, so there's information out there depending on the manufacturer, and I don't want to go too deep into naming companies, but there are companies that put out information like, well, it has to be direct attach. You have to home run every cable like long patch cords everywhere. And that they're used to, data center people are used to structured cabling. And so there's concerns about, well, we really want to do structured cabling because we want to be able to migrate in the future. And so I come in and we talk to them about things along the lines of latency, versus loss, because there's a lot of confusion or conflation between the two of latency and loss. And I think a lot of the concerns are the whole idea of AI is that it's all close together and it acts as all these multiple computers through a fabric mesh network act as one device. And so latency is critical for that. And they're concerned about, well, if we have more connectors in a structured cabling, that latency will be affected. And that's not the case, actually. Latency is purely a factor of distance, but you have to talk to people and help them understand that. And that, loss is another issue that comes up, optical fiber loss or power loss. And that's purely a number of connections and distance for the most part. And so we try to unwind them to where they can have more choices in how they're going about wiring up, if you will, their AI solution set. And they can be quite large data centers or quite, 10 to 20 racks. Either way, the same questions apply. So it's kind of a fun time right now helping people understand what the capabilities of, if you will, infrastructure are for AI.
Yeah, when you're saying that, it makes me think back when storage networks were relatively new. There was a similar kind of vein that, patch panels essentially were the enemy. You can't have patch panels. There's added loss. Wasn't a latency concern then, but it was a loss concern that
Right.
any loss is bad loss. And I do remember, this goes back to the 90s as well, that those kind of surprising conversations of, yes, it's okay to put a patch panel in there and, run a structured cable there and then just patch in as needed, where for people coming out of a certain mindset, it wouldn't even occur to them to have a patch panel and then put in patch cords after the fact.
Well, I think that's exactly right. It depends on where you come from, right? If you're, and most of the clients that are, and like I said, data center people, they're used to structured cabling. And with the introduction of AI, there's been a lot of different wiring, if you will, ideas out there and concerns on that. And, the good news is most of them aren't spread out over gargantuan data centers, right? Or long distances. So loss is not an issue. Latency is not affected by your structured cabling other than length of cable. And that's always pretty small or pretty short, if you will. So once we get them out of that, then it becomes, well, what connections are required for the AI, right? If we just take, for example, the H100 from NVIDIA, that has four mesh networks involved in that. You've got the storage that you mentioned, you've got your compute, you have your in-band and out-of-band. And, so one's copper, that's easy. But the other three can be complex in that they're not those type of connectors. Well, there's a multi-mode APC, which is kind of unheard of, and it's being used with the Mellanox. And so there's things to know about that will help them designing moving forward. And then when you go into the, if you will, the Grace Blackwell or the GB200, the connectivity changes again. It's not exactly the same. In fact, it's almost exclusively, I believe it is exclusively single mode, whereas the H100 is, multi-mode. So there's some differences. And to be honest with you, I'm excited to see what the connectivity is going to be for the Rubin, or if you will, the Vera Rubin combination coming out.
Yeah, it's the changes come fast and furious these days.
Well, and you got to spend a lot of time with customers understanding what they're using and what their needs are. And part of that, frankly, is, on some level, not so much explaining the difference between a CPU and a GPU. Everybody's pretty much got that now. But, when we hear things like HGX H100, and what is that? And how is that different than a DGX H100? And being able to explain the different applications for them on that. And, and then frankly, the H100, as you know, Mike, is pretty much heading towards end of life exceedingly fast with the Grace Blackwell chipset, or even just the Blackwell chipset coming out, and different cabling required, different racks, actually. So, H100s were put on the TIA standard, no problem. You can use those, or you could use an OCP rack if you wanted. But, NVIDIA themselves is using something for the Grace Blackwell called an MGX rack. It's similar to the OCP, but not exactly the same. So we're seeing with each generation of AI, everything can change from power requirements to cable and connectivity requirements to the actual cabinets themselves now are changing. So, I feel really lucky to be connected with Leviton, who is directly connected to NVIDIA, because we get that latest insight into what are the requirements coming, which ultimately makes me more helpful to the clients out there in the marketplace and building good infrastructure for them.
Yeah, so when you think about the various customers, so yeah, some of them are these big, large, multinational, potentially big financial firms, for example, but some of them are smaller. They could still be big, but just relatively speaking, smaller enterprise type firms. How are they dealing with this pace of change? Is it just the pace of change itself that's got them concerned, or is it kind of the specifics of how do I connect my ports together?
Yeah, that's a really good question. And I will say that I'm seeing a mix of, if you will, strategies going there. There are really two strategies. One is you build it now and knowing full well that you're going to throw it away later, which is incredibly wasteful, but the speed and technology, they don't have the time to do it differently, or that's the way they're going at it, is they're just going, if you will, a disposable AI network, if you will, knowing that it's going to be lapped in a year. And it is going to be lapped. We're looking at H100 is 2 years old. And now the GB200 has come in, and I'm skipping through all there's a lot of iterations of this. There's B200, GB200, GB300, I'm not going to go through all those, but the point is that it's revving so quickly. But again, I go back to our roots, and the roots are, if you build it in structured cabling, and this is what I'm talking to the end customers about, put in structured cabling. You don't have latency or loss issues, especially with AI networks. That's even easier for latency and loss concerns. Put in a structured cabling, single mode, and then whatever the connectivity options are, and there are going to be changes in connectivity. This is not LCs and your standard MTPs. You'll be able to migrate, if you will, and not lose your core trunk infrastructure and top of rack infrastructure or even in rack infrastructure. And so that's this other strategy is so you either build it where you can migrate forward and reuse that which you already have, or you build it so fast with the expectation of you're going to trash everything when it's done. And I see both. I don't know that it's right or wrong. I don't have that view, but by my mind, structured cabling is, I hate to throw things away. And the time that's involved in rebuilding it, especially, is key in data center launching.
Yeah, time is a big one. I know for us, that's one of the things that we're always working hard to, whether it's just internal systems or products we develop, allowing people to put things together more quickly so they can, that time to revenue happens more immediately is key with a lot of the stuff.
And they have bigger challenges to deal with than, frankly, cable infrastructure is the easiest part of this formula. Moving from H100, which could be air cooled, to Grace Blackwell, which must be, direct to chip liquid cooled, and the changing in cabinets and all cabinet styles to accommodate that, and power requirements that's what they want to spend their energy and time dealing with. If they do the infrastructure overhead correctly, that part will be easy through all the evolutions. Fiber optic, single mode fiber optics is single mode fiber optics. It's just the number and type of cable or connectors that are put onto the ends of that. And that's where structured cabling migrates so beautifully, which then allows them to focus on the real issues, power and cooling.
Obviously, that's the big, I'll say, headlines today and for the past, let's say, year is kind of the power and cooling. From your viewpoint, how do you see this playing out in the future, like the next 1, 2, 3, 5 years?
Yeah, so when you say the word see, it is me seeing, but it's me talking to people, and the people that I'm talking to who are the most in the know, talking about, if you will, those next generations of the Vera Rubin coming out. This may well be not in a cabinet at all that we know as a cabinet. It could be, when I think of a cabinet, I think of something that's, got rack space, RU involved in it, right? Or, no wider than 30 inches, 24 is the narrow, 30 inches wide, 48 inches deep kind of scenarios. And, the newer versions of this, I imagine we're probably going to see full custom build, and I'm going to use the word metal enclosures with no standardized size that we've seen before, but rather what will accommodate the cooling and the power chassis or the DC power plant in there without any consideration of RU. It's just about density and functionality, and they're not any more limited to the type of what a rack is and standard availability of a common rack product. That's gone with this. There's so much money involved in these types of compute platforms that the cost of a cabinet is, very small in comparison to the dollars being spent on the generating capacity of these compute switches by AI.
Yeah, certainly in the big environments, they're easily dropping $1 billion into some of the shoot infrastructure.
Right, which then unhooks them from having to use anything standardized. They can build anything custom they want and to make it work to the best of the compute fabric, to accommodate that all the fabrics and that ability of the system to have high performance. Yeah. I looked up online for a fun fact, and I was shocked that right now the projected increase in performance over the Blackwell. This isn't over the H100 where everybody's putting in now, right? And Blackwell's going in now too, but it's just got kicked off a few months ago. The projected increase of the Rubin Vera combination is going to be 14 times faster performance than the Blackwell GB300. That's shocking. I mean, that's just, and the power is going to go up and the cooling, everything's going to go up and get larger. It's just, it's hard to imagine and to get the speed at which this is happening. Well, like I said, we just launched H100 less than 2 years ago, was being put into the marketplace, and it's gone.
Yeah, what this also makes me think, Robert? That we're getting kind of old. That, oh my God, this is going so fast, I can't keep up. This down and look at me.
Well, I do remember Category 5 and 5E, and then there was a Category 4 in there for 6 months and stuff like that. But this kind of change is pretty amazing. We are definitely getting up there. Yeah. It's fun to be part of it. Because it's
100% agree.
Yeah, it's never a boring day in the tech world of technology out there.
All right, good stuff. What else do you think is kind of key, like in your, if I can call it day-to-day, in your travels talking to customers about AI or machine learning networks? What?
Yeah. So, I would just kind of wrap it up like this. I would just say the most important piece is, and it changes depending on your client and your client need, and you have to get in front of them and find out what it is. But, I had mentioned it earlier. It's ROI. And, Leviton has coined the term ROII, return on infrastructure investment. And I like that. That really works. It's very poignant to, where we're at now. And for our world, when it comes to cable plants, if you'll allow that term in AI, the conversation's got to start with, are you expecting to throw this away, or do you want your maximum return on the dollar spent? And in future, speed of being able to transition from Grace Blackwell to, Vera Rubin and other generations, right? And if you can have that strong conversation with the right people, almost everybody, realizes that they don't want to lose the dollars and the time to rebuild a network every single time that they have if you will, an upgrade to their network, their compute fabric. And so that conversation leads us into a lot of really fun conversations, and it's the advantage of Leviton. I go right back to the whole idea that Leviton's ahead of the curve. We're going to see new connectivity and, not leaking anything. Obviously, Leviton's in the forefront of that too, and trying to make sure that we're all ready to go. And when those new connectivity systems come down, we'll be able to clip right on to the existing infrastructure. So their deep expertise in supplying solutions for, versus we can do home run direct cabling versus and or structured cabling, puts us well ahead of everybody else out in the marketplace, which, ultimately makes my job a lot of fun to be able to go around and talk to the people and about the further up the technology chain and be able to make good decisions for their cable plants for HPC cabling.
Yeah. I mean, one of the things you said in there, you don't want to necessarily throw all that investment away. I mean, there's this whole sustainability message, which means different things to different people. Could be environmental concerns, could be being able to replicate something. But I think one of the things that's a big issue right now is just labor. If you're taking the time and money to build it now, and that's a challenge in today's environment, you don't want to have to do that again next year or 2 years or 3 years from now. You're making that investment now, just sustainability wise, maximize that use of labor that you've already invested in.
Very valid point. Very valid point. And as we'd already discussed, we're in the right industry because this is the change is not stopping. So it's not if they upgrade, it's how soon they upgrade. And so what we're talking about, return on an infrastructure investment, is more relevant now than it's ever been.
All right. I appreciate your time as always, Robert.
Happy to be part of this. And Mike, I got to say, man, keep those products and smart ideas coming to us. We love it.
Good deal. Thanks, Robert. And thanks everybody for joining us today.
Beyond Bandwidth is a podcast series produced by Leviton Network Solutions. For more information on the topics we talked about today, as well as other enterprise or data center network infrastructure content, or to check out all available episodes of Beyond Bandwidth, visit us on the web at leviton.com/beyondbandwidth or wherever you normally listen to podcasts. If you enjoyed this episode, we'd appreciate you leaving an honest review in your podcast application. Along with word of mouth, leaving a review will help others find our show. I'm Roy Chamberlain, and this was Beyond Bandwidth. Until next time.